Yes. So now we are checking into design constraint options. All of you are into design constraint now. This is the first thing what we need to do. Then we should go into general inputs. Always we should start with the design constraint first. So here by default, the software will show you the default values, what has been setted over there. So if let's say my vessel is having 11 bar or let's say 5 bar as the pressure. So I can put it over here, design internal pressure, which will be 5 bar for all the equipment. So let's say I put 5 bar. So I don't want to put it every time. So if I put it here once, would you like to update the model to reflect these changes? Let's say yes, because we have first created this, right? Otherwise it would not have asked for. Then design external pressure. Let's say our design external pressure is 0. Design internal temperature. Let's say we are having 100 degrees Celsius, which I want for every component to follow. Design external temperature, let's say it is 0. So have you changed this 5 bar 0 external pressure? Temperature is 100 degrees and 0. So can you see this option? User defined MAWP. So this option to be used if let's say you are going to design only some part of the equipment, not the entire equipment. And the other part of the equipment which you have not modeled is having MAWP which is lesser than your vessel MAWP. So in that case, that value can be placed over here. Let's say in case of heat exchanger, the heat exchanger is already in place. It is already functional. Now, because of some reason, its bonnet of one side needs to be replaced. Now you are just modeling that bonnet or channel. Okay. The equipment is already having MAWP, let's say 8 bar. Now the new bonnet what you have created is having MAWP of 15 bar. So are you going to do the hydro for that entire equipment for 15 bar? No. It should be based upon the lowest component MAWP, isn't it? So let's say the lowest component which is already in service, it is at 8 bar. So your new component what you are designed should have MAWP is equal to 8 bar. So there we can put it over here. So mostly it will be done for where you are not having a single model done for the entire vessel, or you are doing only the partial part of the entire model, or there is one component which is or one equipment which is placed over the other. So in such cases, these values to be put. Okay. User defined MAWP and MAPNC. Otherwise, it will always be calculated for the given existing model. Additional operating static pressure. So if let's say there is one equipment mounted over the other and that equipment static head you want to consider in this vessel. So in that case, you can add on that static head. Otherwise, in normal modeling, you don't have to put any value for this. User defined MAWP and MAPNC. These are the options only to be chosen if you are not building entire model in the same Pvelite file. If it is broken model, then the lowest model MAWP we have to put it over here. You are having one equipment like this. And that equipment is having saddle supports like this. On top of this, let's say there is one more component or equipment which is been placed. Let's say it's a vertical exchanger or any other equipment like this. Correct?
Yes.
Now, we cannot model these two equipments in a single file in Pvelite. Pvelite will have a functionality which allows you to model only a single equipment at a time. So now, let's say this is filled with fluid. So I am going to model this equipment. So whatever that fluid is there, I can model that and its static head will be automatically considered. But the same equipment is attached to some other equipment and that equipment is also filled. ultimately the static head of the top equipment will also come on the bottom equipment, isn't it? So let's say from this to this, there is a 0.5 bar static head which is coming additionally. If I'm going to model only this equipment, the software will not realizes that there is a 0.5 bar additional pressure to be considered as a static head. Correct? So in such cases, this option can be used and here you can put that value so that the software will add the static head into your design pressure at the time of designing any component which you have modeled. Is it clear? Then comes the pressure testing options. So now it is very important that the person who is going to choose any of these options should be 100% aware upon the code requirements. If you are not knowing what do you mean by UG99B as per code, what do you mean by UG99C, what is the meaning of UG99B and Note 35, what is UG100? Let's say UG99B uses the equation for the calculation of hydro test pressure as 1.3 into MAWP into static head. So how the hydro test pressure will be calculated? 1.3 into MAWP into static head. That is called UG99B. Then UG99C. UG99C is considering MAPNC. That is maximum allowable working pressure, maximum allowable pressure in new and cold condition. What we have discussed, right? With one example. So it uses that 1.3 into MAPNC. Then UG99B and Note 35. So this uses 1.3 into design pressure into static head, LSR. 1.3 into design pressure into LSR. Instead of MAWP, you can use a design pressure. If you are going to have your hydro test as per UG99B and Note 35.